So friends, welcome back to the presentation. Today we'll be studying about correlation coefficient and how correlation can be used for by business professionals. I am your professor Dibojyoti Bhattacharjee, professor in the Department of Statistics, Assam University, Silchar. So without wasting much time, let's get started. In this presentation, we will be studying about the concept of understanding relationship between some business variables and how we can find out the relationship between two variables with the help of a visual tool called as the scatter diagram. We will also see different measures of correlation like the Karl Pearson correlation coefficient and the Spearman's rank correlation coefficient. And we'll also try to understand when which method is appropriate for quantifying the relationship between two variables. And we will also see how this computation can be done in Excel. And at the end, we will see some business application of correlation coefficient and how it can help us to take strategic decision making. So these are all things that we'll cover in this presentation. Now, let us try to understand that why managers need to know about relationship. Relationship generally, if we look at and tell what is a relationship, there might be an two variables. Simple, we cannot have relationship with a single variable. So far, we were dealing, and most of the things we were concerned with one single variable only. But from this step onward, we will consider two or more than two variables, and most importantly, we will be concerned about the relationship between two variables. We take some examples from everyday business world and try to understand this concept of relationship between variables. For example, here we take the example of say advertising. So advertising and expenditure. Advertising expenditure and sales revenue. That means if I increase my expenditure on advertising, whether it has any impact in my company's product, sale of company's product. So this is an example from marketing where we can be interested in understanding the relationship between two variables, one of which is advertising expenditure and another is sales revenue. In human resource, we can understand the relationship between employee training hours and productivity. So if I give some training to my employees, I expect that the productivity will go up. Now, when I give some training or number of hours my employees are trained, whether it increases the productivity or not, I can understand that with the help of correlation coefficient. And this is how why we must be interested in understanding the relationship. In operations, it might be an example like supplier's price correlate with product quality. So the price of a product, whether it is related to quality of product. So we need to measure something like quality of the product, and price is simple, means whatever be the price tag, that is the price. But we need to identify the quality of product. We need to quantify the quality of the product. Now, if we can quantify quality of the product, and price is already a quantitative thing, so we can find the relationship between these two variables. Finance, it might be interest rate relation to stock market performance. A few days earlier, there was a news that interest rate is to be decreased by the American government. It means that some money from the Americans or those people who are investing in US stock market will be finding or sending their money somewhere else or investing their money in some other market. So that was a very interesting news towards which the Indian, even in India also, people were looking up to, that if there is a rate cut in the US market, by the US government, there might be some amount of money which might siphon from US to other international markets, and India might also take a benefit of that. So sometimes interest rate and stock market performance might be interesting, and obviously if interest rate decreases in India, it will have a direct impact on stock market, that's for sure. But in other countries also, if there is a change in the interest rate, might be there is a slight change in the stock market of Indian stock market performance as well, so that we can quantify, and that's an example of finance. So here in this particular slide, we pick up some examples from different branches of management, and we try to find out that why we might be interested to understand relationship between some business variables. Let us move on. Let us try to understand a scatter diagram. A scatter diagram is a dot diagram, and it is a graphical tool in which along the x-axis we take one variable, and along the y-axis we take another variable. And this plot actually gives us a rough idea about the relationship between the two variables. That is the variable which is considered along the x-axis and the variable which is considered along the y-axis. Before computing the correlation coefficient, plot your data to get a visual inspection of the patterns, outliers, and nature of the relationship. So this gives a bird's eye view or a beginner's exercise that we want to find out the relationship between two variables. First, start with a scatter diagram. So roughly you will get an idea about how the two variables are connected to each other. If there is any pattern, if there is existence of any outlier. Outlier means some values which are extremely large or extremely small, considering the other values of the data set. If the points are widely scattered, a poor correlation is expected between the variables. So these are some identification of the scatter diagram. So let us take an example and try to understand this. So here we have data about age and speed, means age of the rider and speed of the motorcycle. So you must have seen that when you move around, many people means ride the two wheelers, and you must have also noticed that youngsters are in the habit of driving very fast, and they are often very scary. They just cross you in no time, and this sometimes shocks us also, senior people like us. And then we recall, however, we recall of our younger days when we also tried such type of trick. But now that we have become senior, so we get scary at the speed. And so it must be a myth also that young riders drive at a higher speed. So I want to find out a correlation to find out whether there is a relationship between age of the rider and speed in which the rider rides the motorcycle, given a free road or in a normal stance. For that, before going to the correlation coefficient and understanding that, let us actually draw a scatter diagram. So let us see how a scatter diagram is done. Along the x-axis, we take the age of the individuals. So you see age is starting from, I think, minimum age is 16 and going up to maximum is 53. So you should take your x-axis and mark it in such a way that you can space the minimum and the maximum with some amount of buffering in both sides. So I have started from 10, gone up to 60, but you see minimum point is 16 and maximum point along age is 53. So everything can be displayed with some space both in the left and the right side. And then we go with the y-axis. Here we take the speed of the individual. So I think minimum speed you will find here is 30 kilometers per hour. So I have started from 20, and maximum speed is 62. So I have gone up to 65. So I have buffering along the y-axis also, a little less than the lowest value and little more than the highest value. Once we have this, we start plotting the points. So first point is 16 and 62. So from here is 16 and here is 62, and their meeting point is this. So this is the first point, 16 and 62. Then we come to the next one, and that is 22 and 60. So somewhere here is your 22, and here is your 60. So the meeting point of the two, that is this point. Here we draw a dot. These lines and grid lines is just to make you understand where we draw this. So this is my first point is 22. This point is 2260, and like this we have. These are called as data labels. That means what we write here, this along with the point. So let me change the color of my pen. I think it's gone. Yeah. So this is called as the value levels. This is the value along the x-axis and this is the value along the y-axis. So this is x-axis and this is x-axis. Y value, that is speed. So speed is represented by 60 and age is represented by 22. So this is the point which represents 2260. This is the point which represents 1662. 1662. Okay, like this. So like this we plot the points. Now this, how do we understand? Let me strike this off so that we are at a much now. Now if you look at the points, what you see is that you see that there is a points as age is increasing, because this is age, this is age. So as age is increasing, there is a tendency of the points coming down. That means as age increases, the speed comes down. This is speed. Speed. So speed points, these points are coming down. So this indicates that there is a negative relationship. Negative relation means as age increases, drivers will drive at a lesser speed. Because with maturity, they will rely more on safety than on adventure, probably. And so this is a tendency that the speed will come down. So this is what you understand between relationship between two variables through a scatter diagram. Okay. Let us try to understand that how I can understand about the scatter diagram from the means relationship between the variables from the scatter diagram. This one example we have seen. Now here you see these two, here what happens, all the points are in a straight line. That means as x increases, y also increases and increases in the same proportion. So this is called as a perfect positive relationship. Perfect positive relationship. Perfect positive relation. Between whom? Between the variables. Which variable? X and y. That means as x increases, y also have a tendency to increase, and that too in the same proportion. If you look at this, this is also perfect relationship, but this is perfect negative relation. Now what happens here? As x increases, y has a tendency of coming down. So this is called as this case, perfect relation. So this is a perfect negative relation. If x increases, y decreases, and it decreases in the same proportion. So this is a perfect negative relation. So this is perfect positive relation. This is perfect negative relation. Okay. Now this having said this or having shown this, now let us look at transfer our interest towards this. Here you see the points are not in a straight line, but there is a tendency of a cloud like this, that is starting from bottom left and going up to top right. Now if the points are in this way, that is starting from bottom left and going up to top right, then this indicates a positive relationship. Positive relation, but not perfect positive relationship. Sorry. So this is not a perfect positive relationship. Why it is not perfect? Because they have not arranged them in a straight line. But the intention is clear that as x increases, y has a tendency to increase. So this is an example of a positive relationship, not perfect. This is an example. Here you see that if you draw some cloud like this around the points, you will find that there is a tendency of this is perfect. This is not perfect, but this is has a negative relationship between the variables. That means what happens as x increases means as you move towards this direction, the values of y start coming down. Initially it was at the top. As time goes on, as x increases, it comes down here. So this means a negative relationship. That means as x increases, y has a tendency to decrease, but this is not perfectly negative because they have not arranged them in a straight line. So actually, this is an example of a negative relationship. Now look at this. So this is moderate relations. These two comes under these two, 1 and 2 comes under this one, this. And these two, that is 3 and 4, comes under this one, perfect relationship. Okay, now let us come to no relation or no correlation relationship. Now here you see these points, they are not showing any direction, haphazard for different values of x, because as you move from this side to this side, x is increasing, y is sometimes increases, sometimes decreasing, creating a cloud like this, creating a cloud like this. So ultimately, you don't end up to see any relationship between the variables. So this is actually indicating zero correlation or a very negligible amount of correlation. Nothing can be told about how X and Y are connected to each other. So this is an interesting type of diagram. Sometimes scatter diagram has been formed. Sometimes we come across this type of diagram. This is more interesting, the last one that remains. Here what happens, you see, as X increases, initially the points decrease. That means Y has a tendency to come down as X increases. But after a point, say this one, after that when X increases, the Y has a tendency to increase. There are many examples which we can set like this, that initially there is a decreasing trend and then there is an increasing trend, or initially there is an increasing trend, then decreasing trend. For example, when the variable, suppose you put fertilizer in the soil. Now you have an agricultural land, there you are putting fertilizer. Initially when there is no fertilizer, you get some yield. You increase the amount of fertilizer, proper fertilizer, you will find that the yield is increasing. So with increase in fertilizer, yield increases. Then comes a point in which the field gets overdosed with fertilizer, and following which the crop yield starts decreasing. That means initially there is an increase. As X increases, if we take X as the amount of fertilizer used, say urea, and Y is the amount of yield. Now what happens, as X increases, initially Y also increases, but then as X increases, Y keeps on decreasing. Okay, so this is the way in which you might have some relationship. First, this is first initially decreasing, then increasing, and reverse also you can get initially increasing and then decreasing. So this actually indicates, if you calculate the correlation, we'll see later on, it might give you a very less correlation, like close to zero, but you cannot tell that there is no relation. There is definitely a relation, but that relation is not linear. So that is the concept of scatter diagram and how scatter diagram is related to correlation. That means before knowing correlation also, with the help of scatter diagram, we can get some idea about how things are related to each other with the help of this diagram. Okay, let us move now forward. Let us now get introduced to correlation coefficient. Now this is the photograph of Karl Pearson. Karl Pearson is a British biometrician. He actually developed the formula of correlation coefficient long back, and this correlation actually measures the extent of linear relationship between variables. So the correlation measures only linear relationship between variables. Linear means if one increases, whether another increases, if one increases, whether another decreases. That is positive or negative relation. It is unable to find the relationship when it is initially increasing then decreasing, or initially decreasing then increasing. This type of relation cannot be properly computed or quantified by correlation coefficient, which is developed by Karl Pearson. Karl Pearson always did not look like this. He was in his younger days, he was very handsome also, but then at senior age he lost his hair. Okay, this is Karl Pearson in his younger days. Okay, now the correlation coefficient is between two variables X and Y, is written by small letter r with xy in the suffix, indicating that this is the correlation between X and Y. So small letter r is used, and in the suffix the variable. So if you want to find the correlation between speed and age, so you can write this as age comma speed. One thing interesting, that Rxy is equal to Ryx. That means you can take the reverse also. The formula is symmetrical. So if you change the positions of X and Y in the formula, the value does not change. So what is the formula? We'll see soon. Okay, now let us see the formula of the correlation coefficient. There are different same formula only, but you will find in different texts they are produced in different forms. But the formula that we define or we will be using is this formula. This formula is very easy to compute, and handling also manually if we want to compute also, this is relatively easy to understand. So what we have the product of xy. So if I have the variable x, some values of x, and if I have the variable y, so I'll find x into y, and then I take the sum of this. I take also x bar, I take y bar, And so x bar equal to summation xi by n and y bar equal to summation y by n. So there I find y bar. So this is summation x square minus n x bar square and summation y square minus n y bar square. So here I replace the value and I compute and I get the result here. So let us see how this is computed. So this is the formula for correlation coefficient. The correlation coefficient lies between -1 and +1. If it is towards +1, indicates that the variable x and y has a positive relationship. If it is towards -1, it indicates that x and y has a negative relationship. That means if x increases, y will decrease or y may decrease. So this is the how we interpret the correlation coefficient based on the value. That means interpretation of the correlation coefficient is actually making a statement about the relationship between the two variables x and y for which the correlation is computed. Now let us look at this and try to understand. These are all rule of thumb. If we calculate the correlation coefficient and the correlation coefficient comes close to +1, no, exactly +1, then both the relationship, both the variables move in the same direction and also in the same proportion. This is called as the, sorry, this is called as the perfect positive correlation. Now, if the value of the correlation coefficient is -1, and after compute you get -1, it means that both the variables will move in the opposite direction. That is, if one increases, another will decrease, and this decrement will take place in the same proportion. In such a case, we encounter what is called as a perfect negative correlation. And then if the correlation coefficient is 0, we tell that the variables are uncorrelated, means they don't have any correlation. That means nothing can be told about the linear relationship between the variables. But correlation equal to 0 does not mean that the variables are independent. Because previously we have seen an example where I told that if the fertilizer increases, initially yield will increase, and if fertilizer increases more, the yield will decrease because of overdose of fertilizer. So here actually yield and fertilizer are not uncorrelated. I'm sorry. Here yield and fertilizer are not independent. There is a relationship, but there is no linear relationship. So in that way you can tell that yield and fertilizer are uncorrelated. Does not mean that they are independent of each other. So that is the difference actually. If we in plain English, if we tell that x and y are uncorrelated, we mean that they are not connected to each other, they are independent. That is what we mean. But in statistics, when we tell that two variables are uncorrelated, means that the correlation is close to 0. I never tell, or it does not mean that the variables are independent, because they are close to 0 means the linear relationship between the variables. Linear relationship means a constant trend of increasing or decreasing of a variable corresponding to the other. That is not visible, or that is not available in the data. Rather, there might be other types of relationship as well. Now, let us see these cases when the correlation is close to 0 from either side. That means maybe positive, maybe negative. Roughly speaking, positive means there is a positive association between the variables. That is, if one increases, another is supposed to increase. Negative means if one increases, another is supposed to decrease. But these positive or negative values, if they are close to 1, sorry, close to 0, that means say plus 0.2, plus 0.3, minus 0.15, like this type of values which is close to 0, then you may tell that there is a very little correlation between the variables, and well, they are almost uncorrelated. But if the variables approaches 1, say 0.8, 0.82, 0.95, 0.93, in that case there is a high correlation between the variables x and y. That means the variables are highly dependent on each other. That means if one increases, another is also supposed to increase, and if one decreases, another is also supposed to decrease if the correlation is very close to +1. Now, if the correlation is near to -1, that is say 0, minus 0.7, minus 0.85, minus 0.93, some such values, it means that there is a negative relationship between the variables. That means if one variable increases, the other variable decreases and vice versa. So these are some rule of thumb which will help you to understand and interpret the correlation coefficient. Now let us look at this computation of the correlation coefficient. A simple example. Let us see how we manually compute, and then we will also see that how this correlation is done with the help of the formula. So first we have here, let us have this. A marketing manager collects data on monthly advertising spend X in $1,000 and sales revenue Y in $10,000. Calculate the correlation coefficient and interpret the value. So this is the expenditure made by the company on advertisement. So this is 5 means $5,000. 8 means $8,000. 10 means $10,000. Okay, like this. And this is 6 means 60,000. 9 means 90,000. 10 means 100,000. So like this, actually these are the values. So what we have, first let us look at the formula for correlation coefficient. Earlier we told you that this is the formula for correlation coefficient. There are other same formula only can be represented in a number of ways, but we will go with this formula because this formula is actually very useful for computation purposes. So uh, this is XY, RXY, that means correlation between X and Y, that is sales and spend expenditure on advertisement and revenue from sales. Okay. So now this is XY, N X bar Y bar, X square, N X bar square, summation Y square minus N Y bar square. So this is under root. This is also under root. So let us see this summation XY. So what is summation XY? So this is X and this is Y. So we get XY. XY, so this is 6 into 5 into 6, that is 30. 8 into 9, that is 72. 10 into 10, that is 100. 12 into 13, that is 156. And 15 into 16 is 240. So we have multiplied this. Then we require the sum of these columns. So sum of these columns comes out to be 598. We also require x square because in the denominator I will require x square. So I require summation of x square. So 5 square, this is 5 square is 25. Then I have 8, 8 square is 64, 8 into 8, 64. Then I have 10, 10 square is 100. Then I have 12, 12 square is 144. Then I have 15, 15 square is 225. Okay. Then this we add them up. So this is 558. Now we have revenue 6. 6 into 6 is 36. 9 into 9 is 81. 10 into 10 is 100. 13 into 13 is 169. 16 into 16 is 256. So this is 642. So these 1, 2, 3, these values we have. Then the summation xy, we replace it as 598. Then n, that is number of pairs. How many pairs are there? 5 months data is there. So I have n here 5. 10, then 10 is actually the average x bar. So x bar I compute here. X bar equal to summation xi by n. So summation xi, that means the sum of x, that is sum of x is your 50. So I write here 50 divided by number of pairs. So that is 5. So that gives me 10. So y bar is summation y by n. Summation y is 54. So I write 54. 54 by n is 5. So 54 by 5, that is 10.8. So we have these two values. Now we start replacing. Summation xy is 598. Then I have n here 5. Then I have x bar here 10. Then I have y bar here 10.8. So all these things I replace here. I also replace summation x square 558 minus 5 into 100. Then this summation y square is 642 minus 5 into this. All these things we write down. First we compute what is available. So multiply 5 into 100 and then subtract for 558. So 5 into 100 is 500. 500 taken away from 558 will give me only 50. And these we multiply 5 into 116.64 and subtract that amount from 642, giving me 60. In the numerator, we have 598 minus 540. So that gives me 58. And divided by this is this square root and multiplied by square root of 60. So that gives me 58.98. So you can also see like this very shortcut you can do means these 58 and 60. So this is actually geometric mean because you get 58 into 60. The geometric mean, so this will be approximately equal to 59 because 59 is in between 58 and 60. So here you see this. That way, anyways. So ultimately, you get the value to be very close to 1. That is plus 0.99. That means there is a very high positive correlation. It means that if sale increases, the revenue will certainly increase because the correlation is so high that it is close to plus 1. So we make an interpretation that is important. And once you calculate the correlation coefficient, whatever value you get, interpretation is very important because even it is told in the question that calculate the correlation coefficient, nothing is told about the interpretation. Even then we need to interpret because why we are calculating correlation coefficient? Obviously, because we can take a decision, we can understand how the variable are influencing each other. So there is a positive relationship. That means if you increase your expenditure on advertisement, your revenue is supposed to increase and will increase almost in the same proportion. So this is how we interpret the result. Okay. Now, before we go to this slide, actually we actually tell you that what are the other formula of correlation coefficient, other form, same formula of correlation coefficient. First formula Rxy, that is equal to, we start with covariance of xy divided by standard deviation of x multiplied by standard deviation of y, SD of y, SD of y. This is the first formula and the very basic formula. From this only we get this one. Let us look at the second formula. What are the other ways in which you can write this same formula? The other way we write this is like 1 by n, that is number of pairs, summation x minus x bar into y minus y into 1 by n summation x minus x bar whole square. Put it under root. You can understand that this is the standard deviation. Okay, then 1 by n summation y minus y bar whole square. That means standard deviation. So this is another way. And the one in the numerator, that is 1 by n summation x minus x bar into y minus y bar. That is called as the covariance of xy. So this way also we can write, and then there are some other ways also in which same formula. But if you deduce this, if you keep on deducing multiply the terms, so these terms, if you multiply with each other, take the summation, etc., you will ultimately end up in getting this formula. But this formula is for calculation purpose. It is the easiest and can be attained with a minimum number of columns. So that's why we actually prefer to use this formula. Result will be same whether you use the formula this one or use this one. You will get the same value of the correlation coefficient. These are just deduced from one another. Okay, now let us go to Spearman's rank correlation coefficient. So this is the photograph of Spearman. You see there is some similarity. Both of them are bald. Both Karl Pearson and Spearman. Okay. Now what happens? Sometimes the data set that we encounter is actually ordinal in nature. Ordinal means they are in terms of rank. We don't have the actual values, but we have the rank of the uh, pairs. Means data is in pairs. Now you have a set of ranks for corresponding to one variable, and you have a set of ranks corresponding to another variable. That means data instead of numerical values are actually rank data. Now, in such a cases when our rank data is called as ordinal data. Now, when we encounter ordinal data, then one way of computing correlation coefficient is using Spearman's rank correlation coefficient. Here actually we understand the direction of the relationship between the two variables. We are not concerned about the linear relationship between the two variables, which we were concerned when we computed Karl Pearson's correlation coefficient. Here, one big advantage of this is that if there is outlier, very large value, one value very large, since we convert them into ranks, so that does not influence your correlation coefficient. So this is one big advantage of this. Here also the correlation lies between -1 and +1. And the interpretation of the data set value of the correlation coefficient, that is Spearman's correlation coefficient, is same as that of the uh, Karl Pearson's correlation coefficient, like value lying between -1 and +1. If it is towards +1, then there is a positive relationship. If it is towards -1, then there is a negative relationship, that way. One thing more, sometimes we have some qualitative type of data which are in numerical values. Say, for example, beauty and sincerity. So, beauty and sincerity, there is no scale to measure beauty, there is no scale to measure sincerity. In Karl Pearson's correlation coefficient, the variables that we deal with are actually continuous type of variables, and they are those variables which has a universally accepted scale like distance, income, temperature, humidity, blood sugar value, blood pressure, all these type of values, income, expenditure, saving, salary, rate of interest, share price, these type of variables are all continuous variables, and they actually can be considered for studying relationship through the Karl Pearson's correlation coefficient. But sometimes if we have data sets which are not directly measurable, like sincerity, honesty, beauty, intelligence, say quality of a product, performance evaluation. Now, performance evaluation, generally we have a scale on which the measurement is made, not an universal scale, but a scale developed by maybe your supervisor. Such scales, data coming from such scales are actually put to find a relation through the Spearman's rank correlation coefficient. We'll see one such example. Okay, let us move forward. So the formula for this correlation coefficient is given by this 1 minus 6 summation di square n into n square minus 1. Di is the difference of ranks. We will see it later on. N is the number of pairs. Other things you understand. We'll look into di and find out what is di square. Okay. Now, before going to calculation of computation of the rank correlation coefficient, let us look at how we interpret the rank correlation coefficient. Now, if the value of the rank correlation is from 0 to 0.19, that means is it positive, then we tell that there is a very weak positive correlation. If it is between 0 to 0.19, both negative, that means minus 0.19 to 0, that is negative side, then we see that there is a very weak negative relationship between the variables. If it is between zero point 0.2 to 0.39 positive, then we tell that there is a weak positive relationship between the variables. And if it is between minus 0.39 to 0.2, then we tell that there is a weak negative relationship between variables. Similarly, zero point 0.4 to 0.59 indicates moderate positive relationship if both the values are positive. If it is between minus 0.59 to 0.4, then we tell that there is a moderate negative relationship between the variables. If the variables are having values, if the rank correlation coefficient is having values between plus 0.6 to plus 0.79, then it's a strong positive relationship between the variables. And if it is between minus 0.79 to minus 0.6, then we tell that there is a perfect negative, strong negative relationship between the variables. And more than 0.8, then there is a very strong positive, or less than minus 0.8, then we tell that very strong negative relationship between the variables. So here we are to find out the relationship between two attributes. One is performance and another is emotional intelligence. Now, what happens? Let us assume that I am working in a company, and in my organization there are 10 people working under me. Time has come to evaluate them. So I have evaluated them. And the score in X is actually a marks given by me out of a 10-point scale to the employees uh, by their supervisor, that is me. So first one I have given 7.1. Second person I have given 7.4. This is dependent on the way they have taken my orders, their punctuality, their sincerity in work, their the amount of trust that I have in the quality of their work, etc. And Regarding the number two, that is emotional intelligence, which is represented by score of Y. Emotional intelligence is the ability of an individual or intelligence of an individual to understand others' emotion, to control one's own emotion, and to understand what motivates others, what encourages others, and how people can means that you don't get carried away in difficult situation emotionally. So this all makes up an emotional intelligence. Emotional intelligence is very necessary for a manager because they need to understand what boost others, what actually make others feel better, and make the work environment uh, work culture friendly. So this is emotional intelligence is very important for a leader, for a manager, for a good teacher, etc. So nowadays, emotional intelligence is often spoken about, and it is expected to be a higher level, in the next level than intelligent quotient (IQ). It is earlier IQ was given very much importance, but now EI, that is emotional intelligence, is considered to be that IQ is considered to be a subset of emotional intelligence. Emotional intelligence is an umbrella term. It is assumed like that. Okay, let us not go to the discussion on this. So I have two groups of employees, sorry, one group of employee. I have their score on performance, which is given by me, but the score on emotional intelligence is on a 10 point, sorry, 100-point scale, and it is given by their peer group, that is people with whom they are working directly at the same level, so that during the interaction what other people feel about you, that marks is given out of 100. So that is how this, now you can see this, that the scales are not same, but it doesn't hamper the computing of the relationship between the two variables. Here we are not concerned with the employees or the individual or their average score. Rather, I want to find out whether the performance is somewhere related to emotional intelligence. So if I find that there is a positive and high positive correlation, it means that a emotionally intelligent person, an emotionally intelligent person also can give good performance, and vice versa. Okay. Now let us go and see how this is computed. What I do is that I convert them into ranks. That means we go to performance indicator first, and whoever having the maximum value of performance indicator is given the rank 1. For example, I find that the maximum value is obtained by 9.6. So 9.6 is given rank 1. Next in the series, who is the second position? 8.8. So 8.8 is getting rank 2. Next in the series, who is getting the maximum position value? That is 8.3. So 8.3 is given rank 3. That means we rank them in descending order. So this way, I finish ranking of this first individual. And then the rank of Y. Now we come here, we find out that who is having the maximum value here? 81. So 81 is getting rank 1. Then I find out who is the second individual with maximum value score in emotional intelligence. Calm down, I think it's 78. So 78 is given rank 2. So this way, in the same fashion, actually, going from top to bottom, that is in descending order, we get the rank of X and we get the rank of Y. Once we have this, now we find the difference of ranks, that is Rx minus Ry, or you can do Ry minus Rx also, because after that we square it up, so whatever negative things are there will become positive, so it doesn't matter much. So 7 minus 6 is 1, 6 minus 7 is minus 1, 4 minus 3 is 1. So this way I actually take the difference of ranks. Now in the next step, each individual term is squared up. 1 square becomes 1, minus 1 square becomes 1. So this way I go on, and then I find the square of all this term. This sum of this column, that gives me summation di square. Now let us look at the formula of rank correlation coefficient. The formula of rank correlation coefficient is given by 1 minus 6 summation di square n into n square minus 1. Now di square is 12, n is the number of pairs here, so pairs is 10. So that is all. So we just replace the value. In case of di square, we put 12 because the sum of that column has come up to 12. And then we compute it, getting the value to be 0.98. So this is positive. That means there is a high positive relationship between performance indicator and emotional intelligence. That means as the performance level of the worker increases, the emotional level also increases, or you may tell in the reverse order, that a person with higher emotional intelligence will definitely be a good performer. So if you can understand the emotional intelligence, you can actually understand the performance level as well, and vice versa. So this is how the rank correlation coefficient is very high and close to +1, indicate that there is a high positive relationship between performance and emotional intelligence. So an employee with high emotional intelligence shall also be a good performer and vice versa. So that is the interpretation. So whenever you compute the correlation coefficient at the end, you need to go up with a interpretation of the values that you have got. Now let us look at one important warning, because we generally don't tell about this to a student of statistics, but managers need to know it, because whenever you calculate the correlation coefficient and you find the value and then you tell that, well, these two are related, this causes that, this is not done, because the high correlation does not mean that they are the cause and effect relationship is there between the two. That is, one is the cause of the other, that is not fact. Actually, here we take a very interesting example. It is a very well discussed example. One person, he has collected the data about sales of ice cream in different months in a town, say. So, if January, February, and of a particular year, he has computed or collected the data of ice cream sales throughout the year. So, these are the ice cream sales. As you can see in winter, November, December, January, February, the price of ice creams sale goes down. Very few people are consuming ice cream. But during the summer season, as you can see, this period, May to September, it's thick. That means a lot of people are actually consuming ice cream, and so the sale is going on high. Okay. This individual has also collected the data about the drowning incidents. That means number of people who had died due to drowning during these particular months in that particular town, maybe, or in that particular state. In January, 5 people died. In February, same year, 8 people died. In March, 15 people died. And here also you see that from April onwards till October, there is a high number. After that, there is a decrease. After that, there is a decrease, that November only 10, January 6, December 6, January 5, 8, which same as that of ice cream. So if you calculate the correlation between the two, needless to say that the correlation will be very high. If you look at the graph, this is giving the ice cream sales. So it is going up like this and coming down. Same is the pattern in case of number of deaths due to drowning. And so this is the same pattern. So obviously they are moving in the same direction. And if you compute the correlation coefficient, because this will be a Karl Pearson case, because these are quantitative things. Uh, so no point of going with the Spearman's rank correlation. So if you compute, the correlation will be very high. We can see this correlation how to compute also later on. Now correlation will be very high. Mm, Now, if you tell that ice cream has some relationship with drowning incidents, that means as ice cream consumption increases, drowning also increases. So the safer thing to do is that let us stop selling of the ice cream. Let ice cream be banned, because if ice cream consumption increases, then actually drowning incidents will also increase. But the thing is not, ice cream is not responsible. There is a hidden third variable, and that is the season, temperature, daily temperature or monthly average temperature. Now, what happens? You see, April, May, June, July, August, September, October, say till September, these are summer months. In summer months, people consume more ice cream. In the summer months, people go more for swimming. They go to the swimming pool, they go to the beach, because it's summer, it's hot, so they just want to cool off. So they go to some pool, they go to some swimming pools, they go to some maybe seashore, go to some, visit some river destinations, and so they swim and get drowned. So it is the summer which is responsible. High temperature leads to this type of one-side ice cream consumption. So there is a hidden third variable which actually influencing both the variables. And when you can compute the correlation between the two, you will be fooled, finding that the correlation very high, leading to find that or conclude that ice cream consumption is actually controlling the number of deaths. So if we can control ice cream consumption, then the number of deaths due to drowning will come down. So this type of error should not be done. This is an interesting example where we see that, well, mm, there is a correlation, but that is not the causation. Okay. But if you see, if you think in another way around, say alcohol consumption and number of road accidents. Now, alcohol consumption goes up Then road accidents also goes up. Now, whether this can be a cause or simply a inflated correlation, think as a food for thought for you. Okay. Now let us go for a actually comparison between the two types of correlation coefficient. First type of correlation data type is continuous, which is also called as interval data or ratio data for Karl Pearson. For Spearman correlation coefficient, we have ordinal data, or we might have continuous data which we will convert into ranks. So it can deal with continuous data also, Spearman rank correlation coefficient, but ultimately correlation we have to go for computation of the ranks and then compute the correlation. The relationship between the variable is linear. That is what we measure in Karl Pearson's coefficient of correlation. In Spearman correlation, we don't speak about the linear relationship. We understand the monotonic relationship, if any, between the variables. Sensitivity is correlation. Karl Pearson's correlation is sensitive to outliers. If there are suddenly some very big values or some very small values, they might influence the value of the correlation coefficient. But in case of Spearman's rank correlation, since we convert them to ranks, so this particular abnormal control is lost by a variable. Calculation. Based on the raw data values, we can actually calculate the correlation coefficient, Karl Pearson's correlation coefficient. But Spearman's correlation coefficient cannot be computed from raw data. We have to convert it into ranks. Usage, how strong is the straight line relationship that we understand? Maybe positive, maybe negative, but whether there is a linear relationship between the variables, that is studied by Karl Pearson correlation coefficient. And Spearman's rank correlation coefficient studies monotonic relationship, that is if the variable increases, other variable is what is happening to the other variable, whether it is increasing or decreasing. But we don't look into the type of relationship or whether it is linear or some other type of relationship through Spearman's rank correlation coefficient. So this is the difference between the two. If we want to compute in Excel, then we put this command correl, correl. Then we get those values, those cell where we have stored the first set of observations, and then comma, and then we give the cell address of those variables where we have the second set of observations. So this is, suppose I have the first set of variable occupying A1 to A10 and the second set of variable occupying the cell B1 to B10. The values should be in pairs. We cannot have unequal number of values, and in that case the correl A1 colon A10 comma B1 colon B10, close the bracket, press enter to get the correlation coefficient. This A, B, etc. you can write in small letters also, because Excel is not case sensitive. Now, for Spearman's rank correlation coefficient, we do not have any direct Excel function like Corel, but we can use it. How? First, we use the Corel function later on after ranking the data set. So, how to compute the ranks? I have some variables. I want to compute the ranks. So, if the data is already you have the ranks, then you just can use these ranks and use the Corel function to compute. If the data are numerical values which need to convert into rank, then you can use this rank dot average ABG, and within the bracket you will have the cell address that will convert the set of values into the corresponding ranks, and then we can use the rank correlation coefficient. So let us see how we compute this exactly in Excel, because I have given you the formula, but process little bit explanation I feel that it is required. Now we have come over to Excel, and we can see that we have already typed in the data. So first data is related to age of the rider and speed of the motorcycle, average speed of the motorcycle, that information we have. Now we want to compute Karl Pearson's correlation coefficient. As we have discussed, the formula for that is CORREL, correl. So when you type in, you will find that already this information come. Then you start with the bracket. Then you include the entire data set. First, the variable values under the first variable. Don't select the name of the variable, because that is a non-numeric value which will not allow me to compute the correlation. and then you give a comma, and then select and drag and select the other variables, and you have to see that they are equal in number, both first variable values and number of values under the first variable and number of values under the second variable. They should be equal in number, and this is the case, and then you close the bracket and just press enter, so you get the value of the correlation coefficient, Karl Pearson correlation coefficient. So minus 0.72816 indicated there is a negative relationship between age and speed of the uh, motorcycle, age of the driver and speed of the motorcycle. Now we come to this same data set that we used earlier during the presentation, that is variable X is actually the score on the performance of 10 employees, and variable Y represents the score on the emotional intelligence of the 10 employees, which is given by their peer group. Now I want to compute this. Unfortunately, in Excel, we don't have a direct formula of computing the rank correlation coefficient. But we can handle it by using a function. So I come here, I write here equal to rank, and then you will find that when you type in rank, you will find that rank average, rank dot abg. So you just click here, so rank average comes in. Now you click and drag to this value. No, not like that, not so easy. So first you write F2, because I want the rank of F2 corresponding to all the values in this particular set. So then I give comma, and then from F2 I come down to F11. Okay, so this way I get the rank of the first value. So in this entire set, the rank of A is actually 7. Okay, now we can proceed forward next, but how a click and drag and get the other result. What I do here, that when I write rank, here you can see in the formula bar, formula is coming F2, leave it alone. But the series, that is F2 to F11, there you use dollar before all F. So before F, $1, after F, another dollar. Then you come back F2, then we have F11. So before F, $1, and after F, $1. So we press and we get 7. Now why we have done this? Because as we click and drag, it will pick up the next value 7.4, 7.9. In this way it will pick up. But I want to evaluate 7.4 given the entire data set. It is rank of 7.4 in the entire data set starting from 7.1 to 6.6. That means whenever I click and drag, I want the values to change, but the set of values within whose rank is to be computed should remain the same. And that's the reason why I have put dollar before and dollar after F, so that it does not move as we click and drag. Now we click and drag to the other values. So accordingly, the set remains the same, but the value of the variable keeps on changing, and so we get this. You may check it out manually also one. So that maximum value is 9.6, getting rank 1. Second maximum, I think, is 8.8, so it is getting rank 2. Third maximum is 8.3, getting rank 3. Least of the lot is 5.9, and that is getting rank 10. So I am satisfied with this. Similar exercise I do here. So I type in equal to, then I write rank average, rank dot abg. It already comes here, rank average, and then I click on this value. So G2, what is the series? Series starts from G2 and goes up to G11. So I click on this. Before I press enter, I can make the correction here by putting a dollar before G, and then once again after G. Then in the other G also, last value of the series, that is G11, I put a dollar before G and after G, so that when I click and drag, it does not slide down, so that the set remains the same. So when I click and then I have this, this is equal to, now we have the ranks. Now we can use the Correl formula itself, CORREL, Correl, and then we give this first series is this. Don't take the name of the variable, it will not be computed. And then I give the second series, so this is the second series. I close the bracket and I press enter, so I get the value of the rank correlation coefficient. So this is the way how we can compute the Karl Pearson's correlation coefficient and the Spearman's rank correlation coefficient. Now let us look at some real world mm, uh, examples where we can use the concept of correlation coefficients. to understand and solve different types of business problems or to for making of strategy. First is the portfolio management. Portfolio management in a concept where we actually invest our money in different stocks in such a way that our total amount of money get diversified. Means if you put all your money in the same stock or similar type of stocks, then with the up and down that takes place in the market or in a particular sector, you may be a loser also, because if the market goes down for that particular sector, all your stock will go down. So we generally prefer to diversify. We want to put our total money in different stocks so that even with the up and down of the market or up and down of the market in sector wise, some of the sectors might be doing well so that I can get a benefit even when some of the sectors are not doing well. That is in short or in layman's term what is portfolio management. Now in portfolio management, correlation comes handy. If I have the stock prices of a particular company X and the stock prices of another company Y for last 10 days, and if I calculate the correlation, and if the correlation is very less, uh, close to zero, then we understand that they are not connected to each other. That means if the stock price of one of the of X increases, the stock of Y may increase, may not decrease, may increase, may not increase. So that they are independent. Or rather, if they comes out to be negative, it means that if stock price of X increases, the stock price of Y will decrease. So it is also a good diversification. Like if your by chance your one of the stock fails, then other stock will give you the support. That is hedging will be done. So this is a very important tool for portfolio management. Marketing, you can calculate the correlation between customer demographics and purchase behavior for a target, for a particular type of campaign or for a particular type of population. If you find that people of a particular age group having more inclination towards a particular product or towards a particular marketing promotion, then you might actually target your audience for a particular type of promotion. So this helps in strategy formation. In supply chain or in operations management, correlation between the raw material price quality and the production line downtime, this can be correlated. This is just an example. There may be so many. This is one example where we can use the correlation to understand the relationship between the quality of the raw material and production line downtime. In HR, the correlation between employees' engagement score and the performance of a particular department can be correlated to understand how the employees' engagement helps to what extent the departmental performance, or it is nowhere related to the employees' engagement, etc. So these are some examples. You can actually expand beyond these examples also. This is just a starting point. So what we have learned in the entire presentation. Let us make a summary of the takeaways. First, we learned that this is actually studying relationship between two variables, and these two variables might appear from different or similar type of business problems. And I want to find out whether they are connected to each other. If connected, then which way they are connected. We have started with a scatter diagram and we have tried to understood how visualizing the scatter diagram we understand relationship between two variables. We can also be able to identify the outliers from scatter diagram. Then we learned about the Karl Pearson's correlation coefficient, which is denoted by R. And with the help of that correlation, we understand the strength and direction of the linear relationship between two continuous variables. We then go forward to study Spearman's rho, which measure the direction of the monotonic relationship between two variables, and it is more specific to ordinal data or data which is available in terms of rank. We have also seen that in such a type of correlation, that is a rank correlation coefficient, if the data is in qualitative nature, means comes from a qualitative source, and even there is no universally accepted scale, so we can gainfully use Spearman's correlation coefficient. And since the correlation is based on ranked data, so the outliers could not influence much in case of the measurement rho. We have taken a very important note of the fact that correlation may not lead to causation. Some cases they may lead, but not always. So we cannot generalize that correlation means high correlation means one is the cause of the other, because there may be a hidden third variable which might be influencing this. The use of two Excel functions like Correl and rank average we have seen how we can go ahead and compute the correlation coefficient without by avoiding numerical or manual computation. With the help of Excel, how we can compute both Karl Pearson's correlation coefficient and the rank correlation coefficient. Lastly, these tools help to move business decisions from intuition to data driven insight. So just not to go by your gut feel, but a correlation helps us to understand relationship between variables, and we can go ahead in an objective fashion. Thank you for watching the video. I end up with a quotation that correlation is the foundational tool for root cause analysis and predictive modeling. If you want to look at predictive modeling, correlation is the first step towards that. Thanks once again for your patience listening to this particular lecture. Hope to see you soon again.